The question today is on three-dimensional geometry, and the question reads: OABCD is a right pyramid on a rectangular base with AB 8 centimeters, BC 6 centimeters, and OA, OB, OC, OD are all 13 centimeters. So we have the diagram as shown. Then calculate part A, the height of the pyramid, then part B, the inclination of OBC to the horizontal, then part C, Roman 1, the angle between OB and DC, and Roman 2, the angle between the planes OBC and OAD. So right to the first part, we are to determine the height of the pyramid, and the height of the pyramid is determined as follows. So in the question we are told that the pyramid is a right pyramid, so we have right there. So that simply means that the apex is vertically above the center of the base. So if we drop a line right from the apex to the base, then the line meets the base at the center of the base, and that line is the height of the pyramid. And again, remember, the height meets the base at 90. So for us to know the length of the height, then what you're simply going to do is we are going to use this triangle right here. So let's call this point here X. So we're going to use triangle OXC. So before we use triangle OXC, remember we only know the slant height, which is 13 centimeters. We do not know the height and we do not know the base. So at least if we know the base of the triangle, it will be easier to determine the height. And the base of the triangle XC is part of AC. So AC lies on triangle ABC on the base. So first let's get the size of AC. So we will extract triangle ABC and have this ABC. So here is 90. So that is at that particular point. And then AB is 8 centimeters, BC is 6 centimeters. So using Pythagoras Theorem, we will be able to determine the length of AC, which is the square root of base squared, that is 8 squared, and that is 64, plus height squared, that is 6 squared, and that gives us 36, so that we have root 100, and that is 10. So if AC is 10, we will come here and determine that the size of XC is simply a half of AC. So from X to C, we have it being half of AC. Remember, point X is the midpoint of the base, and therefore AX and XC are equal. So we will have this as XC is a half of AC and AC is 10. So XC is 5. So with that, we can now extract triangle OXC. So here we have X, here O, and here C. So already we know what XC is, that is 5 centimeters. And you know the slant height OC as 13. Therefore, OX, which is the height you're looking for, will be able to obtain using Pythagoras Theorem. So remember, at X, we have the angle 90. So this implies that the height is equivalent to hypotenuse squared, that is 13 squared, minus the base squared. And that gives us, that is the square root of 169 minus 25, and that is the square root of 144, and that gives us 12. centimeters. So the height of the pyramid is 12 centimeters. Next, we are required to get the inclination of OBC to the horizontal. That is the angle between plane OBC and the horizontal. So the horizontal is the base ABCD, and we have OBC. So for this case, we have two planes inclined to each other. So the angle of inclination between the two planes is simply the angle between the following lines. So remember, plane OBC and plane ABCD meet along the edge BC. So we will draw lines on the two planes, and the two lines should meet somewhere on the edge, and each line should meet the edge at 90 degrees. So we have a line on OBC as shown, meeting the edge at 90. We also need another line on ABCD, meeting the same edge at 90 degrees. So the angle between the two lines should be the angle between the two planes. So let's call it theta. So if we call this point Y, then we will extract triangle OXY as shown. So we have O, X and Y, and for this case we are looking for angle theta, which is at this particular point. Theta here is 90, and if you look at this diagram, the length from X to Y should be a half of AB, which for this case is 4 centimeters, and already the height we know is 12 centimeters. So what we're simply going to do is to have XY as 4 centimeters and OX as 12, and that means that the angle theta will be obtained by simply saying tangent of theta is equal to opposite over adjacent, which is 12 over 4, and that is 3. And therefore the angle between the two planes is obtained as the tan inverse of 3. So that worked out should be 71.57 degrees. Next, for part C, we need to get the angle between OB and DC. So in the diagram, we have OB is right here, OB, and DC is on this other end. So one thing we need to note is that the angle between OB and DC is the same as the angle between OB and AB. Remember, AB and DC are parallel and equal, and therefore the angle between OB and AB will just be the same as the angle between the same OB and line DC. So we will just extract this OB, AB, so the triangle right there. We have the triangle as follows. So here we have AB. Remember, AB here represents DC. So for point A we have D, and for point B we have C. So at this point still O. So remember, from A to B the length is 8, and OB we know is 13. So we can still do that. Here is 8 centimeters and here is 13. And then we have some height drawn there so that it bisects line AB or DC if you like. So from this point to B we have 4 centimeters. So remember, the angle between OB and DC is this particular point here. This angle, let's call it theta again, so that we consider the right angle triangle, which is half of this whole triangle. So here we'll have adjacent and hypotenuse, so that is cosine. So you say cosine of theta is equal to adjacent, which is 4 over hypotenuse, and that is 13. So that the angle between OB and DC is simply theta is equal to the cosine inverse of 4 over 13, and that will be 72.08 degrees. Then lastly, for Roman 2, we are required to get the angle between the planes OBC and OAD. So we have the planes right up here. OBC is here, OBC and OAD. So if I may have it here, we have something like this. This is A, B, C, and here is D, and then we have O there. So we need the angle between OBC and OAD. So if I may draw a line here and another line here, remember these two lines lie on the two planes in question. So what we are simply going to have is the angle between the two lines. That will be the angle that we are interested in. So let's call it alpha. So we may complete the triangle so that if we call this point Y and this other point Z, and remember the length from point O to the middle of the base is still the height h, and if we call this x as we had determined it earlier on, so it is still x. So we had AB as 8 centimeters and BC obviously 6, but that we are not interested in now. So we are interested in XY, and XY is half of AB, so we have 4, and the height we already had as 12. So if I may extract that triangle, we have this as Z and this as Y, and then here is O, and then here the height is 12, which is perpendicular to the base, and then here is X, here is 4. So the angle between these two planes will be the angle up here, so the whole of this. So if we call just this part here, let's say beta, and this other one also beta because they're equal, then considering half of the whole of this triangle, which is a right angle triangle, then we will say the angle beta is related to these sides as opposite and adjacent. So we use tangent, so tan beta is equal to opposite, which is 4 all over adjacent 12, which is a third, and therefore beta is the tangent inverse of a third, and that is 18.4349. But remember, the angle we are interested in is the whole of this, which is twice beta. So alpha is equal to twice beta, which is twice beta, and twice beta, that is 2 by 18.4349, and that finally gives us 36.8699, and rounded off to 4 significant figures, that is 36.87 degrees. So that is it for this question. Thank you for watching. Hope to see you in the next video.